Hey everybody, this is Todd Frazee, and this is the programming video for Fusion 360 TCOSE-09 part. Okay, well first we're going to open our design. You should already have it modeled. And it should look something like this. It's got a manhole cover, sort of. And it's a head plate for the steam engine. And we're going to switch to manufacturer. Now I want to speak about one thing here. If you did not revolve your part, the lathe package is very dependent on following a linear path. Assuming you've already know you're going to model the part as a turn part, you would have a sketch that could be enabled. If you don't have that, please go to the video on how to extract a section profile video and resume with this video after you've completed the necessary sketch. The sketch should look like what follows. If you open from the browser, models, then the model, and then down to sketches, if you revolved your model, you should have a sketch that looks somewhat like this. And if you don't, again, go to my help video that'll help you generate a sketch that appears like this. We need it visible in the machining package. So if you have a sketch that you can enable and make visible like I just did, we'll go ahead and proceed. Alright, so the first step on this is a thin part. It's debatable on whether it's better to mill or circular interpolate this on a mill or turn it on a lathe. The opposite part that goes on the head looks like it's advantageous to turn that one. But this part will have to be first turned, and then these holes would be done on a mill unless you had a live tooling lathe with a live y-axis. We don't, so we're going to use the technology we have. So I'll have two programs. One will turn the part, and then you'll take that part, put it in a fixture, and drill the holes on a mill. So let's go to the turning package first, and you should have a series of icons. You might not have this many. You can always find them from the list below. Alright, so we're going to create a setup, and it defaults to milling. We're going to switch to turning. And you should get it should change to a cylindrical stock profile. It may not look like this. You may need to change the orientation of your X, Y, and Z axis. At this point in the course, you should be fairly comfortable with manipulating that. I happen to have mine default to where it would be natural to machine this part on a slant bed lathe. All the moves on a 2-axis lathe are in Z and X axis. And on a slant bed lathe, the tool actually comes in opposite of the operator facing upside down, and that way the chips fall with gravity. Okay, continuing on. So we have this face here is our rotary axis, and then our x-axis, you could select even one of those lines. So mine's in the correct orientation. We're going to go to our stock definition. We're going to change it from a fixed size cylinder to a relative size cylinder. Now I'm looking at the diameter of our part, and it's 19.07 is 3/4 of an inch. So that's really close, but not enough material for us to machine off the outside and have it round. So we're going to go up to the next 1/8 inch, which would be 7/8. And it looks like the default diameter is somewhat close to that. So it would be 0.875. Okay, we're going to put in a radial offset of 0.062, which gets us close to 3/8, and then we're going to round up to the closest 5,000. So that gets us right at 8,875 thousandths, which is 7/8. On our front side offset, we're going to put 0.03. Then on our back side, we're going to put 1 inch. Now that's the minimum we're going to hold on to. We might have a longer bar than that. And on our setup, we have 400 thousandths of it projecting from the back of the part to the chuck so that we have extra material there. So we're going to move on, and we're going to move on to post-process. We're going to call this 0901, and it's going to be op1 lathe. Now we know it's a lathe program. We're going to put 1 on our work coordinate system. Okay, we'll select OK, and we should have our setup all set up. Alright, now the first operation we're going to do is we're going to face off this material. So we're going to use a facing operation, and we're going to select tool number 2 to do that work, and from our Titan library. We're going to leave all of these at default. We're going to move on to geometry, and we're going to base it off model front. So just double check the orange plane is on the front of your model, front being the right and the chuck would be on the left. And we have a series of cylinders instead of planes because it's rotary motion. We're going to leave our retract plane at 40 thousandths from the face. Our retract, we're going to leave that at 20. Or outer radius, we're going to leave the same. It's stock OD because that's what we're starting with. The inner radius, we'll go ahead and do stock ID, which is actually 0. But we're going to do a distance to cut below inner radius. And what that'll allow us to do is have the facing cutter go a little bit past center to make sure we don't get a little island or dimple in the center if the tool's not set exactly precise. So we're going to go 0.01 10 thousandths past center line. Then we're going to go to passes. We're going to leave all these at default except for we're going to select multiple passes, and we're going to include a finish pass. Alright, so we have 30 thousandths to remove. I would suggest we do a 0.02 step over, and then we're going to do 1 step over, and our finishing step over will be 0.005 for a nice finish cut. Alright, we're not going to leave any stock to leave, and we're going to go to the linking tab. We're going to leave all of these at default. We want the 45-degree lead in that helps it start and gauge the work at an angle. Lead out's not as critical, comes out at 45 degrees, and the same as lead in can be fine. We're going to select OK, and we're done with that routine. Okay, the next step is we want to turn the outside down. So we have a fair amount of material there. We are going to go ahead and do a roughing and a finish. So we're going to go to Turning Profile Roughing. And this is where we need to select our sketch. So to do this, we're going to use the same tool we used in the last operation. We're going to move to Geometry, and we're going to select the Model tab, and we're going to select our sketch. Now we get the full perimeter of the sketch, but we're going to constrain it to just cutting the outside diameter. Okay, so we want to add tangential extensions. So for the front of the part, we want to put 0.01. That's just to ensure that we're coming in outside of the work. And now we're going to go down to tangential extension on the back. We're going to part this off with a tool that is 3 millimeters wide. That is 118 thousandths. We need to go past a little bit more than that so that that tool does not have to rough down to diameter. It'll do less cutting. It's more efficient. So we're going to do a tangential extension of 125 thousandths, which is an 1/8 inch. Okay, we'll move on to diameters. Okay, we're going to base everything off stock except for our inner radius. Our inner radius is going to be the model outside diameter. So this will make sure that everything we cut will be cut no further than that dark blue cylinder. We're going to move on to the next tab, and we should be able to leave much of this at default. The depth of cut there, let's put that at 30, and we're going to leave 4/1000 for our finish cut to remove. We'll go to the linking tab, and we'll leave all this at default as well. And then we'll select OK. Alright, so we came in and we took a couple passes and then did a final roughing cut, leaving 4/1000 for a finishing routine. Okay, so we've machined the face. Now we've machined the outside diameter, major diameter. Now you go onto the turning finish profile, and we want to base this off the same tool, same feeds and speeds. We're going to select model. We're going to select the same profile we selected before. Model front, we want the same parameters we put in here, the roughing. So tangential extension, 10/1000, and tangential extension on the back is going to be 0.125. Okay, we're going to go to, now you could use this rest machining, but on a straight cut there isn't any material, and that means that the cutter is only going to come back and cut what was left by the previous cutter. That's more effective when you're using two different tools that have different nose radiuses. Okay, so we're going to go to clearances, and we're going to leave all these at the default except for the inner radius is going to be again based off the outside diameter of the model. We're going to move on to the passes tab. We're going to go front to back. In computer, we're going to do one step over, and that step over needs to match the amount of material that was left behind by the roughing cut. So that was 4/1000. Go to the linking tab. We're going to leave all this at default. Our lead-in angle, though, is going to be 0. And we don't want to lead out. We'll select OK, and we get our finish cut. Now we can move on to making this feature here. We're going to make that feature with a grooving tool. So we're going to select turning single groove, and you're going to select tool number 4 from the rocket library. So this is tool number 4. We're going to leave all the feeds and speeds at default. We're going to go to geometry. And what we want to select is the corner of the end of our groove. So it's going to come down this line and cut to there. And we want to base our reference off the front of the tool. Okay, and so it puts the front edge of our tool on this blue line, and it's going to feed straight in like it's doing a groove. Well, it isn't a groove, but it's a shelf, and it should machine to that. Okay, we're going to go to the next tab, and we're going to leave a lot of this initial stuff. We're going to put our clearance on model OD because it's already been machined down in that area. We're going to put our outer radius at model OD also, because that's where we want to start our grooving operation. And then we're going to set our inner radius at a selection point. And that selection is going to be the OD of the boss. So the end result was we should be cutting between the cyan line and the dark blue line, coming straight in and then pulling straight out. Okay, let's go to passes. We're going to set all these at default. We're going to move on to linking and leave all these at default. Hit OK. Alright, so we have our grooving tool. It's going to wrap it this way and then feed into our workpiece and make a corner. Now it's actually going to leave a really small fillet here. The best way to handle this if we were actually machining these parts would be to put a corresponding radius on the inside of the cylinder, break the edge so that that matches nicely. Alright, so we have one more operation, and that's going to be using the same tool to part this part off from the stock. So we're going to go to turning part. It's automatically going to default to the back of the part. And we're going to leave all the settings at default on the first tab. On the geometry tab, we want to make sure it's on model back. We want to make sure that our blue line is to the left. And we're going to go to radii. Now what do we want to go from? We want to go from the stock OD, which is fine because we have extra stock out here. Don't want to run into that. Our outer radius, that actually can be set at model OD because we've already taken the diameter down in the area we're machining. And then our inner radius is going to be based off the stock ID, which is 0, and we want to go a little bit past, so we're going to go 0.01 past, so we make sure that we release the part completely. And we'll select OK. And there's our cut. Alright, so let's simulate what we've done so far so you can visualize it. Highlight setup 1, and then we're going to do simulate, make sure the stock is selected, and play. So here we're facing the front of the part. Now that's roughing the outside diameter, coming back, finishing the outside diameter. Comes in with the grooving tool, parts it off with the grooving tool. Alright, so you have this little disc that pops off. So the only thing left is to come back on a mill, and you make some sort of fixture to locate this, and drill these 4 holes. So let's do that. We're going to go back to the milling package, and we're going to create a setup, and we're going to call that setup 2. And now we're in mill mode. Now if your origin is not facing the way it is here, you're going to need to manipulate that by using model orientation and such. What we're going to do is we're going to go to stock, and we're going to do a from solid because we've machined almost all the material away, and we're going to use the model as our solid. We're going to go back to setup, and we're going to set our origin. Now there's different schools of thought. We could set it here, and you can set your tools and go from there, or it can be the bottom. I'm going to go ahead and use the, it looks like my model origin's where we'd want it to be. So again, change this to Z-axis plane and X-axis if you need to reorientate the gnome. If you already have the origin on model, then you won't be able to move it. But this is set up in the orientation that we would most likely machine this. Alright, so we're going to go over to post-process, and we're going to call this 0902, and it's going to be op up 1 mil. And we want work coordinate system 1. Let's hit OK. And now, if we have a 2mm drill, we could use that, or you could use a circular interpolation with a 1/16 end mill. Okay, so our last operation is going to be to drill these 2mm holes on a mill. You have to have a fixture to locate them. We've created our setup. Now we're going to go to drilling. We're going to select the TCOSE library, and then we're going to select the tool 12 for the 2mm drill. And we can leave these at default, and geometry, we're going to select this hole, and we're going to select all that are the same diameter, so it gets the other 3. We're going to go to heights. We'll base it off stock top. That's fine because the stock is the part itself. Hole top, the top height's the whole top, the bottom is the whole bottom. We're going to break through the bottom, and we're going to go an extra 0.01 10,000ths. Make sure we cut all the way through. And then we're going to use a pecking drill, even though it's not going that deep. We're going to do deep drilling. And that looks good. Although I like round numbers in my code, so you don't technically have to do that, but makes for a shorter line of code. And we'll go OK. And we've got a drilling cycle. Now it'll be important to keep this because you want to program the -10 part, which has the same hole pattern, and we can literally just copy this tool file to the other file when you get to programming the other part. Okay, we're done, and we'll simulate this, and should be pretty straightforward. Wrong stock though. Let's make sure you get the right thing highlighted. There we go. And then make sure your stock's selected, and we have our drilling. So you will need to submit one lathe program and one mill program for setup 1 and setup 2, setup sheets, and post-process code for credit for this assignment. And again, save this work and program part number 10 after this one because we'll be referencing this file. Thanks a lot, and I'll see you on the next one.